Let's get right into today's explainer, folks, because we are looking at a literal game changer for Web3 developers today. We're talking about seamlessly fusing artificial intelligence with real-time on-chain data. And the best part? Doing it without sacrificing even a single drop of accuracy. It's all made possible by Etherscan's Model Context Protocol, and I'm super excited to unpack it with you. So, what actually happens when an AI just hallucinates your crypto portfolio? Let's dive right into this. If you've ever tried asking a standard large language model to check out a blockchain transaction or, analyze a smart contract, you've definitely hit that frustrating wall. Standard AI models, they are notorious for either straight up guessing data, hallucinating, basically, or just getting totally blocked by CAPTCHAs when trying to scrape block explorers. It's wildly frustrating when you need cold, hard, verified truth, right? To fix that, here's our roadmap for today. We'll start with the Web3 AI problem, then cover what Etherscan MCP actually is. After that, we'll hit tracking blocks and transactions, verifying smart contracts, monitoring network gas, and wrap up with access and rate limits. Section 1, the Web3 AI problem. And this brilliantly illustrates exactly what we're up against. Standard AI search tries to act like a regular human clicking around the web. But because of that, it gets slammed by security CAPTCHAs. Or worse, it just confidently fabricates numbers when it gets blocked. Etherscan's MCP, on the other hand, is a direct API wrapper. It entirely bypasses all that messy web scraping and feeds your AI verified on-chain truth straight from the ledger. It's literally the difference between asking someone who heard a vague rumor versus reading an official bank statement. Section 2. What is Etherscan MCP? Okay, let's break this down. The Model Context Protocol, or MCP, is essentially an API wrapper standard. Think of it as a highly specialized translator, a truth filter, if you will, for your AI. It gives your AI model a predefined list of tools it can call to look up verified information right through the Etherscan API. Etherscan actually hosts a streamable HTTP MCP server just for this. And what's absolutely incredible here is that it's not just locked to Ethereum mainnet. This protocol connects your AI to over 60 supported chains. That's huge. To really put this into perspective, look at what beta users are already pulling off with this access. Developers are building AI agents that can automatically compare a live deployed contract's behavior right against its original Solidity code. We're seeing customer support bots instantly verifying if a user's cross-chain bridge transaction actually went through. Plus, people are building these incredibly accurate real-time portfolio management agents. This is happening right now. Section 3. Tracking blocks and transactions. Now, what's really interesting here is how effortlessly your AI can read the ledger using these specific endpoints. By just calling something like the get transaction by hash endpoint, your AI pulls exact verified transaction details. Boom, done. It can fetch block info by its number, count up the total transactions from a specific address, or just pull the exact native balance of a wallet. You literally don't have to build complex backend logic for this anymore. Your AI requests the tool, and Etherscan just hands over the data. Section 4. Verifying smart contracts. These are the heavy-hitter smart contract tools available through the MCP. Imagine just chatting with your AI and casually asking it to pull the exact application binary interface, the ABI, or the source code of smart contract. It happens in seconds. It can grab the creator's address, the exact transaction hash used to deploy it, the whole 9 yards. It can even trigger verifications for standard Solidity contracts, ZK Sync, proxy contracts, and even stylus source code over on Arbitrum One and Sepolia. It basically turns your everyday AI into an on-demand expert smart contract auditor. Section 5. Monitoring network gas. So, the crucial point to note here is understanding exactly what your AI can access based on your Etherscan tier. Now, every developer can use the Gas Oracle endpoint, which is awesome because it gives your AI real-time gas price recommendations to help optimize when you send transactions. But, and this is important, if you want your AI diving into historical trends, stuff like the daily average gas limit, the daily average gas price, or the daily total gas used, those are specific pro endpoints. You'll need a standard plan or above to unlock those. And hey, remember when I said earlier that this whole thing goes way beyond just Ethereum? Well, the Gas Oracle tool perfectly illustrates that. Your AI isn't just stuck monitoring gas on Ethereum mainnet. It can see across Polygon, BNB Smart Chain, Moonbeam, Moonriver, Celo, Gnosis, and Linea. Having that multi-chain visibility, that is absolutely massive for AI agents that are trying to efficiently route transactions across the entire Web3 ecosystem. Section 6. Access and rate limits. Okay, let's talk about how you actually scale this up. If you're just dipping your toes in and testing the waters, the free tier is great. It gives you 3 calls a second, up to 100,000 calls a day on selected chains. Plenty to get started. But as your app blows up, you can scale right through the light, standard, and advanced tiers, all the way to the big leagues, professional and pro plus. Those top tiers give you a blistering 30 calls a second and up to 1.5 million calls per day. So whether you're coding a quirky little personal AI assistant or a massive enterprise tracker, there's absolutely a tier for your traffic. Before you run off to start building, though, do not forget the simplest but literally the most vital step of the whole process. To actually access the streamable HTTP MCP server, you just have to authenticate using your standard Etherscan API key. You just pass it as a bearer token right in your header. It's seriously that straightforward. So, we've broken down the headache of AI hallucinations, we've looked at the clever structure of the Model Context Protocol, and we've walked through those incredibly powerful endpoints for fetching transactions, verifying contracts, and monitoring gas. Really, the only thing left to do is put this into action. So I'll leave you with this. How are you going to use Etherscan's MCP to give your AI a verified, totally hallucination-free connection to the blockchain? The tools are sitting right there, the data is rock solid, and the possibilities, well, they're pretty much endless. Thanks so much for hanging out with me for this explainer, and happy building!